Hi, and welcome to Math 243. This is the first day of statistics, and you can get this packet online, if you don't have it already, at caraleemath.com and print it out. That way you can follow along. And today we're going to cover sections 1.1 to 1.3. Before we get started, I want to just scroll down and show you this graph. If you've never thought about having a job in statistics, this might change your mind. Look at the job growth from January 2011. This only goes up through 15, so 2 years ago. And the blue line is for data science. The orange line is for big data. And you can see the practically exponential growth of these jobs. My hope is that you will love statistics so much that you might want to look into this. Even if you don't consider it as a career, you'll be using statistics most likely in your job, whichever it is. Whatever it is, which is why you're taking this class. So let's get into statistics. Let me move this up a little bit. This is section 1.1, Intro and Key Terms. So the first question I have for you is, what are data? And I'm saying what are data because data is actually the plural. Datum is singular, but you don't hear that very often. So data, I'm going to have you pause the video for a minute so you can think and write down, and I will also pause it and write down some answers, and then we'll meet back here. So go ahead and pause now. Great, so we're back, and I'm guessing you probably said something like this: information, values, measurements, possibly answers to questions. Anything along those lines is correct. So I have a question for you though. Here are some numbers. Is this data? Well, they are values. We don't know where they're coming from, if they're measurements or answers to questions. And in fact, we really don't know anything about these numbers. There's no units. So something is missing. We need a little bit more than just the values in order to be data. What we're missing is the context. We don't know where, when, why these values were collected. So yes and no, this is data, but this is only part of the data. I just got this pen, so bear with me. I'm learning to write legibly with it. So we have part of the data. What's missing, or we are missing, the context. So today we will be talking a lot about the context for our data. One more question before we do that. Why do you think the field of statistics is important? This is another one we would discuss in class, but I'd like you to pause the video, write down some ideas, and then we'll start again. Okay, you may have said something along these lines. Why is the field of statistics important? We want to be able to make predictions based on the past. We want to make evidence-based decisions. We hear this a lot in social science and lots of places. Evidence-based means we have collected data. And also data can help us to recognize trends. Excuse me. So let's go to some of the vocabulary that we're going to be using this term in statistics. Here's an example. Researchers are interested in how many people have been evicted from their housing. Draw a picture representing the population and a sample. So these are two vocabulary words. Population is the larger group from which we're drawing. So I'm going to draw a big circle for the population. So you could say this is the entire group that we are interested in. Entire group. Okay, so that would be if we were going to ask everybody If they have been evicted from their housing, that would be the entire population. However, it's usually pretty impractical to do that. So we are just going to, usually, we find a subset of people, and that is our sample. That is a subset of the population. Oops, that's not a T. Subset of the population. Okay, now let's look at our particular example here, and I want to change the color for a minute to write out the population and the sample for this example. So we're interested in how many people have been evicted from their housing. What would the population be for that? Who could be evicted from their housing? Well, these would be renters. Homeowners could be foreclosed on, but not generally evicted. So we're talking about renters. And another consideration is, are we looking at just renters in Portland, Oregon? Are we looking at the U.S., Southeast Portland specifically? So all of that would need to be defined. So let's say renters in Portland, Oregon. This is just an example. We would need to know the actual, more information about this to make this more specific. But we always, when we're defining things, we want to be as specific as possible. So just as an example, we'll say renters in Portland, Oregon. That's for the population. Now, we're interested in how many people have been evicted from their housing in Portland, Oregon. We only want to take a sample of that population, so a subset. So we will talk about sampling methods later on in this course, but as far as actually how to get this sample. But let's say we're going to ask 100 people, and that would be our sample. So 100 looks like a Pac-Man. Let me back that up for a second. 100 renters in Portland, Oregon. Okay, so you see the difference between the sample and the population? The sample is generally a small subset of the entire population. Let's go to page 2. Here's another example with some more vocabulary. Student Services is interested in how many hours students spend on campus when they're not in class. Identify the population, the sample, the parameter, the statistic, the variable, and what the data would look like. Now, if you want to try this, go ahead and pause the video, at least maybe for the population and the sample. You can try it and then start it back up again. But I'm going to go ahead and draw. I like visuals, so I draw the big population. Okay, Student Services is interested in how many hours students spend on campus when they're not in class. So the population, if we're talking about PCC, would be PCC students. Now, we don't know if this is across the district or just at Southeast or any particular campus. We also don't know exactly what the sample is, but we know it would be a small subset. So our sample, let's again, I just like the number 100 today, say 100 PCC students. There's lots of different ways of selecting those students, which we'll talk about later on, about how to get a representative sample. Okay, so we've got our population and our sample. Now we need to talk about parameter and statistic. Okay, the parameter goes with the population. And I need to change the color of my pen again. Let's go with pink. So the parameter is the actual value for the population. So parameter goes with population, which is nice because they both start with P. Parameter, population. The thing is, we don't know the parameter. That's what we need statistics for. So this is usually unknown. So you can think of it as a theoretical or true value. I'll put that in quotes because we don't know what it is. That is what we're trying to estimate. So let's write that too. What we're trying to estimate. Okay. So along with parameter goes with population, statistic goes with sample. Also very convenient that they have the same letter. Statistic starts with S and sample starts with S. So the statistic is the number we get from the sample. So this is the value calculated from the sample. And this is an estimate for the parameter. This is an estimate for the parameter. So let's read the question again. Student Services is interested in how many hours. So let's really get specific about this. How many hours students spend on campus? So this is actually the variable. How many hours? How many hours of what? How many hours students spend on campus when they are not in class? When they're not in class, okay? So the variable, let me make a little more space. The variable is what we are measuring or asking. So in this case, it is the number of hours. Students spend on campus. when not in class. And the units are very important. So the units would be hours. Let's put a little arrow there. If it's a numerical quantity like this, we always want to pay attention to what the units are, the number of hours. So our statistic would be a number of hours. The variable has two aspects to it, the statistic and the parameter. The parameter would be the actual true number of hours that students spend on campus when they're not in class, but we don't know this exact value. What we can find out is a statistic. Take a sample of 100 PCC students and ask them, how many hours do you spend? The other thing that's not in here is this per day, per week, per term. We need to be a little more specific. But if we ask them the question, then we could calculate this, get all this data, and calculate our statistic from that. So, the very last part of this question, what would the data look like? So that's always really helpful to visualize. What is this data going to look like? That really helps us zoom in or narrow down on what information are we collecting. So the data would be, since we're interested in the number of hours students spend, so the data would be a list of the number of hours for each student. Number of hours for each student asked. Great. So now we have gone through a lot of vocabulary words. Population, sample, parameter, statistic, variable, and talked a little bit more about data. Let's go back. We talked about that context with a list of numbers that didn't have anything associated with it. We had no idea what the situation was. And let's talk about the context. So the data is meaningless without the context. There are 6 W's, and if you've ever taken a writing class or journalism class, you've probably run into the W's. Identify the who, what, where, when, why, and how. Those are all good questions to ask to determine what the situation is. So here's an example. Example 3. In performing research for an ecology class, students at a college in upstate New York collect data on streams each year. They record a number of biological, chemical, and physical variables, including the stream name, the substrate of the stream, which is limestone, shale, or mixed, the acidity of the water in pH, the temperature in degrees Celsius, and the BCI, which is a numerical measure of biological diversity. I don't know much about what these mean, but if you're in biology, you probably know more than I do. Okay, so let's talk about the 6 W's. Well, one is an H. Who, what, why, where, when, and how. The who are the respondents, participants, subjects, or experimental units that are being asked or measured. You could also think of it as the sample. The thing that's tricky about the who is it's not always people. So you might think, oh, the who are the students in the ecology class. But actually not, because we're not measuring the students. We are measuring what? Can you guess? They collect data on streams each year. So the who are the streams. So we're measuring, collecting data on the streams. So think about experimental units that are being asked or measured. That's the key information there. Okay, the what is the variables, things that are being recorded or measured. So we could have a lot of these, and we want to include the units wherever possible. That way we know what we're talking about. So here in our example, it says they record a number of biological, chemical, and physical variables, including the stream name. Okay, let me change my color real quick. Okay, the variables, including the stream name, substrate of the stream, the acidity of the water, the temperature, and the BCI. So those are all our variables of 1, 2, 3, 4, 5. Okay, so let's list those. Stream name. That doesn't have any units with it. Substrate. Now that doesn't have any units really, but it does have 3 categories, 3 possible answers. Limestone, whoops, limestone, shale, or mixed. Acidity of the water, and that has the unit is the pH scale. That's pH. Then the temperature and the BCI. Temperature, very important to know that it's in Celsius, not Fahrenheit. And the BCI, we don't have any units given on this. It says a numerical measure of biological diversity. It could be unitless, or it could be something that biologists would know. Okay, we've got the who and the what. Next we need to go to the where. Where is this study happening? Well, we know that the college is in upstate New York. We don't know for sure where the streams are. Are the streams in New York? Are they going out, measuring streams local to their area? Are they going throughout New York? Are they going to the US? We're not sure. So it doesn't say. We're not sure. The college is in upstate New York. But we don't know where the streams are. This is important because what if we wanted to compare their data with streams in Portland? We don't know if they're comparable or not because we don't know which streams were actually measured. Okay, let's go back up. When? The time of the data collection. Do we know anything about the time? Well, it does say they collect data on streams each year. Circle that. Each year. So this is something that they're collecting over time, but we don't know what year they're in right now. The data is collected every year. Ideally, it would have to be the same time every year in order to compare. Okay, why is the purpose of the data collection? Have they told us anything about the purpose? It says performing research. So this is another thing that we don't really know. We want to try to infer if we can. Think about why they might be doing this. So why do you think they might be doing this research? To learn about streams, maybe to notice what's happening with streams over time, look at trends. So it's not explicitly given. But we can infer. So for research, all right, maybe, since we are inferring. Maybe for research, let me back up here. Maybe for research, and to look at trends over time. Maybe they want to monitor the health of the streams. Okay, it's good to kind of get in the researcher's head. Why are they doing this? And the very last of the W's, which is the H, is how. How are they collecting this data? So let's see if there's any particular information given on how. It does say they record a number of biological, chemical, and physical variables, including the stream name, substrate of the stream, acidity of the water, the temperature, and the BCI. So things like the acidity, temperature, and BCI would probably be measured. The stream name and the substrate are information that they could collect. Observation, maybe, the substrate. So we're going to say something like direct observation and measurement. All right, in some cases it might be a survey, if we were getting information from people. Great, so that is one example, and you'll have more in your homework that you can try. One example of reading all about the context in a situation. Very important to actually know what you can do with this data based on what it represents. Okay, let's move on to types of data. So we've seen some variables already and a little bit about data. So before we do types of data, if you're in my class and you haven't already, you can log in to my PCC and D2L, which is, there's a D2L login link on the first page on the left, about halfway down. Log into our course, and on the Content tab you'll find a link to the Math 243 class survey. Please do that if you haven't already. It is anonymous and no identifying data is collected. This is data that we'll be using throughout the term, and it's also going to help us right now look at different variables and the types of data. Okay, go ahead and pause the video if you need to do that, and then come back. Okay, so if you're back, variables are the characteristics that are being recorded or measured. Those are the variables. Just like with the streams, it was the substrate, the stream name, and the temperature. There are different types of variables. We've seen some of these already. Categorical, also called qualitative or nominal. Categorical means there are certain categories, usually a set number of categories that the data falls into. A great example of this would be eye color. It's not a number. So eye color possibilities could be brown, blue, maybe hazel, and green. That's a categorical variable. Let's go over here to quantitative. Quantitative is also called numerical. So think quantity. Quantitative is quantity, whereas qualitative is quality. Quality would have to do with the color, names of the colors. Quantity is a number. I've had students tell me also that they use the N in quantity to remember, or quantitative, to remember that it's numerical. Okay, so this is a numerical value. A good example from the stream was the pH level. That is a number. Okay, now quantitative variables can be continuous or discrete. So the best way to show this is on a number line. If the value only takes on whole numbers, trying to draw a circle here. But it thinks I'm trying to open a window. Okay, let me switch to lines instead. Let's say our variable can only have the values 0, 1, 2, 3, 4, etc., not 0.5, 0.25, 0.999. That is discrete. So a discrete value, think of shoe size. Shoe size might be 10, 11, 12. It could be 10 and a half, so you could go on the half sizes. Still discrete though, because you wouldn't have 10.25, 10.333. That is discrete. Continuous can take every value in the number line. So let's say if you're measuring temperature very specifically, and you could have, let's say you've got a digital thermometer, so it could be 72.3 degrees, 72.4 degrees, 72.35 degrees. That would be continuous. Continuous. Okay, so continuous, it takes on every value. Discrete, only set number of values. Okay, so those are our two main types of variables, categorical and quantitative. We have a couple more, identifier and ordinal. Okay, identifier is an interesting one. That is a unique way to identify someone. It has to be unique to the subject or the experimental unit. So unique way to identify the subject. Can you think of something that would be an identifier? For PCC students, their identifier usually is the G number. That is a number that is unique to each student. Some people might have the same name, but they would have a different G number. For the United States, there's a Social Security number, SOC number. Also, sometimes there might be a customer ID. Think about Amazon. Anyone who's ordered from Amazon probably has a customer ID number. Also, maybe a driver's license ID. Or any type of ID number. That is an identifier. Even though it's a number, I wouldn't necessarily say that it's quantitative. So one test I use is, would you average those numbers together? Would you take an average G number? Now that doesn't make any sense. So I wouldn't call that quantitative. I would call that an identifier variable. Okay, the last one we're going to talk about is ordinal, and the word inside here is order. You have seen a lot of these in surveys. This variable has a ranking. It's a ranking or order to the variable. So something like, could be a number, 1, 2, 3, 4, 5. Or it could be something like strongly, I guess 1 would be strongly disagree, up to strongly agree. Something like that is an ordinal variable. Great, so those are the types of variables. Let's go to the next page, page 4. Okay. Now, these are the variables from the class survey you took, if you're in my class, or if you're just using this for reference. These are the questions that were asked. And now, instead of filling in the answers to the questions, what I want you to do is look at this page and write down what type of variable it is. So, is it a categorical variable? Is it quantitative and discrete, quantitative and continuous, ordinal, and or, because sometimes more than one of these apply, or is it an identifier? Okay, go ahead and pause it. Write these all in the best you can. Guess if you need to. And then come back. Okay, so we're going to write these in together, or you can check your answers. So how do you identify your gender? On my survey, I had some options: female, male, non-binary, or other. And this is one example of a way to ask gender in a more inclusive way. If we just put female and male, that can be excluding some people that might not feel female or male. And also say, how do you identify your gender? Because that may be different than someone's gender assigned at birth. So the way I asked it, and the way it's usually asked, this is categorical. Another good way to ask it is just leave a blank. Let the person fill in how they identify. Still categorical. About how many credits do you take each term? That is quantitative. And then, is it discrete or continuous? I would say discrete, because you can't take 10.5 credits. You can take 6, 7, 8, 9, 10, 11, 12. That is a discrete variable. Okay, about how many hours are you employed each week? Also quantitative. That's a numerical value. Now, would this be discrete or continuous? That's a good question. Might you work 20.5 hours, 20.25 hours? It's possible. We might not write. You might not say 20.33. Depends how close you measure it. So I would say you could say either one for this, I think. Discrete or I think you could argue discrete or continuous. Siblings, how many siblings do you have? Also quantitative. This one, definitely discrete. You cannot have 2.5 siblings. Okay, choose one of these numbers at random. This is an interesting one. Some people may have said ordinal. It is quantitative because we have numbers. Well, we could actually say, categorical. All right, actually, after thinking about it, it actually is categorical. So I would say this is categorical because there would be the number of people that chose a 1, a 2, a 3, or a 4. We wouldn't average these. Like a 2.3 doesn't really mean anything in this case. It's also not ordinal because even though it goes 1, 2, 3, 4, it's not implying any order to these numbers. It's just saying choose one of these numbers at random. So that's why I would call that one categorical. Okay, which award would you rather win? Academy Award, Olympic Gold, Nobel Prize, or none? That is another categorical. How many piercings do you have? Ear, nose, etc. 2 ears count as 2. That is quantitative. That is a number, quantitative. Oh, discrete or continuous? Discrete. I don't think it's possible to have 2.5 piercings, but if you think it is, let me know. How many tattoos? Also quantitative. Continuous or discrete? I think you could argue either one on this. Last term, my students told me that a tattoo could be partway finished, and so you could actually think of it as continuous. So I'm going to say discrete, abbreviate, or continuous. Do you have children? Yes or no? That is not numerical. That is a category. Categorical. Number 10, overall, how satisfied are you with PCC? Rate on a scale from 1, which is low, to 5, which is high. That is, you guessed it, ordinal. There is an order to that. And the last one. Which of the following pets do you have? Check all that apply. Dog, cat, fish, other. Those are categories, not numbers. So again, categorical. Great. So that's it for page 4, looking at all the different types of data. Okay. Now we're going to look at one of these variables from our class. Section 1.3 talks about frequency tables, and for our class we're going to skip cumulative frequency, so you don't need to worry about that in the book or in the homework questions. Just do the either frequency or relative frequency. Okay, so a frequency table, we're going to start to analyze our categorical data now. We're going to look at some categorical variables today. So a frequency table uses category names for each row, and then it records the total count of each value. So a relative frequency table, and a relative frequency table gives the percentage in each category. So using our class data, create a frequency table and relative frequency table with award as the categorical variable. Now you can go to, if I have posted the results from our class data, right now I'm recording this before class, so I haven't done that yet. But if we have done that in class, you can go to that in D2L. I'm going to put in some numbers from my last term class. So in my last term, 3 people said they would like to win an Academy Award, and this is going into the data that everybody put in and counting. How many people said Academy Award? 5 people said Olympic gold medal. 11 people said Nobel Prize. And 5 people said none of the above. Alright, so those are called the frequency or the counts for each category, the number that's selected each category. Well, in order to do the relative frequency, that's a lot more useful usually to know what percentage of people said each type of award. So to get the percentage, first we have to add these up to know how many people we had all together, and we had 24 people. You can double check that that adds up to 24. And then to do our relative frequencies, we're going to take the part out of the whole. So 3 out of 24. and it comes out to 12.5%. On your calculator you would get 0.125. Move the decimal over 2 places, so 12.5%. Similarly, for a gold medal, we would take 5 out of 24. And that comes out to 20.8%. These might be rounded off, I can't remember. Nobel Prize was 45.8%. So type these in and double check. Make sure you know how to get these numbers. And none was 20.8%. There's not really a right or wrong decimal place to round to. Just be sure you round correctly whatever place you choose. So that's how you get the relative frequency. Okay, now we're jumping around a little bit in the first few sections of this book. Going back to section 1.2 on displaying categorical or qualitative data. There's 2 ways to do this, bar charts and pie charts. And we're going to use Excel in our class because Excel is a really good tool for displaying categorical variables. And it's a professional tool, something you'll most likely have access to in your job and be expected to use. So I will be switching over to a different video to show you how to use Excel, but let's just see if there's anything else I want to tell you first. Yes, okay, so we're going to go over 2 tools, how to make a bar chart and how to make a pie chart. If you want to, you can pause and go do those videos first. But I want to talk about, to finish this video, when to use bar charts and pie charts. So you can use a bar chart or frequency bar chart for, they have to be categorical. Variables. Also, you can use a pie chart. For example, if I scroll back up, in a pie chart, these would be the percentages of the pie. So a pie chart would be a great way to display this data. Or a bar chart would have a chart of 3, 5, 11, and 5, or these percentages on the bar chart. There is one time when you cannot use a pie chart, though. So let's go back to the variables on page 4. One of the variables on the class survey cannot be displayed on a pie chart. Which one and why not? So let me go back up to page 4. Now we're only looking at categorical. So let me go back to the top. Categorical, gender, could use it for that one. Numbers at random, we could use it for that one. Nobel Prize, we just said we could use it for that one. Do you have children, yes or no? Which of the following pets do you have? This is the one we can't use. Can you think about why? It says check all that apply. So someone might have a dog and a cat and a fish and a rabbit and a snake and a horse. They have just checked multiple items. And if more than one person does that, your percentages are going to add up to over 100%. So we cannot use a pie chart if you can check multiple options. So let me go back down. Okay, so it is the pet variable. Let me write the pet variable because more than one option can be selected. Let's end that sentence. The percentages will add to more than 100%. Okay, great. So I hope this video has been useful to you, and look for a link on categorical.com for how to make the bar chart and the pie chart in Excel, and we'll be using this data right here. And then on your last page of your packet, you have some examples of what these look like. Here's one bar chart with the frequency. The count is the scale. Here's the relative frequency where the percentage is the scale. It's really important to label these really well. Have a meaningful title, label your axes so that people will understand what this represents. And here's a pie chart for the choice of a word. All right, that's the end of this video. Thank you for watching.